What's up? It's Dr. Taylor Krick, host of the Autoimmune Doc podcast, and on this YouTube channel, I review studies that relate to topics that are covered on the podcast, and just topics that I think are interesting. Microbiome, vitamin D, circadian rhythms, autoimmunity, toxicity. Just kind of cool stuff that's out there in the literature. I have thousands of studies on my computer. This one is directly related to a podcast episode. So I just did an episode. I think it's 25 or 26. I think it's maybe 26. And it's about toxins and autoimmunity. So I talk about some specific toxins, but one of them I talk about is BPA. So this is a really, really cool paper that's kind of an older paper, but it's really good. And yeah, so there's a lot to it too. So it is written by Dr. Kharrazian, who's one of my mentors, and it's in the journal Autoimmune Diseases. So 2014 journal Autoimmune Diseases, and it's a review article called "The Potential Roles of BPA Pathogenesis in Autoimmunity," and so yeah, it's old, but that's why it's interesting, because now there's more literature that has come out, and what they now say is that they call BPA like a familiar face in the autoimmune puzzle, or in the mosaic of autoimmunity, and different things like this. So Dr. Kharrazian, back in the day, no Harvard, wasn't doing the Harvard Medical School yet, but yeah, so BPA is a monomer found commonly used in plastic goods. Although much attention in recent years has been placed on BPA's impact as an endocrine disruptor, it also appears to activate many immune pathways involved in both autoimmune disease development and autoimmune reactivity provocation. That's why this is really interesting, because what we see clinically is that BPA can trigger autoimmune flares. So Dr. Kharrazian's research that he publishes is often due to things that he's either seen personally or things that he's seen clinically, with regards to, he's got some personal connection to Hashimoto's, and that's why he's passionate about studying it. But also some of the things that we see clinically are that, like, BPA triggers flares. So then what are some of those mechanisms? And that's the beauty of this paper, is it's not a clinical trial, it's a mechanism-based paper, and it's saying this is how what we see happening, this is how it can be happening. This paper, the literature is void of good studies basically linking BPA to autoimmunity. Paper explores the impact of BPA on immune reactivity and the potential roles that these mechanisms may have on the development, the onset or exacerbation of autoimmune disease, the development or the provocation of autoimmune diseases. Potential mechanisms may include all these things that we are about to talk about extensively. And he goes through these, suggesting that BPA has a role in the pathogenesis of autoimmunity. So, again, this is a heavy paper too, but there are some good pictures. BPA, blah, blah, blah. It's used in plastics, utensils, toys, water bottles, fax papers, receipts. It lines the inside of cans. Plastic water bottles, obviously the most famous source. Electronics, just BPA in plastics. Temperature leaches BPA into food and water products, as does acidic pH of liquids or of soda can or something like that. Dermal contact with sales receipts can lead to BPA exposure as well. It's been studied extensively as an endocrine disruptor. Numerous papers have shown that it may impact perinatal, childhood, and adult health. Has the ability to bind estrogen receptors, has potential adverse neurologic effects, especially with respect to fetal brain development and the promotion of neurodegenerative diseases. So there is a lot to this. And it says this paper explores the worldwide exposure to BPA and its potential role in the growing epidemic of autoimmunity. So potential role, some of the potential underlying mechanisms. So let's get to some pictures. So here's some of the potential roles. These are the things that this paper basically goes through, is this thing each one by one. So I don't even know where I should start. estrogenic activation of immune responses. One of the pictures shows that, but it's an estrogen mimicker. It has estrogen mimicking properties. So because it can look and act like estrogen, it can activate some estrogen specific immune responses. It can activate Th17. That's a big deal. Th17 is what does tissue damaging autoimmune inflammation. We do not want to activate tissue damaging autoimmune inflammation. It can suppress Tregs. Tregs basically balance this fire out. So they're like the water and this is the fire. You don't want to pour gas on the fire and you don't want to get rid of all the water. That's for sure. It causes some Th1 and Th2 polarization. And in reality, what it does is it shifts towards a Th2 polarization. But yeah, shifts and disrupts T cell balance. Yeah, I have a whole podcast about T cell polarization if you're more curious about what's a Treg, what's a T17, what's a Th1, what's a Th2. That's what the entire podcast is about. Promotion of hyperprolactinemia, we're going to look at that because there's some pictures of that. Promotes B-reg activity, regulatory B cells. BPA can bind protein, which changes the epitope. It's then now a foreign protein. So when it binds to your DNA or it binds to your tissues or it binds to, thyroid receptor or something like that, then you have a new tissue, and then that can be marked as foreign, which is then, an autoimmunity. It can amplify antigen-presenting cell activity. So dendritic cells amplify their activity, which can lead to loss of tolerance, leading to an overactive immune response. It can lead to molecular mimicry with certain tissues. It can promote nitrosative reactions, LPS and cytokine-induced nitric oxide synthase, activate these Th17s again, and then disrupt detox, cytochrome P450 activity. That alone is a mouthful. Those are all the potential mechanisms, and this paper continues to go through them. It talks about hepatic biotransformation, and the detox of BPA depends on a little bit of everything. Phase 1, Phase 2, glutathione, glucuronidation, conjugation. Healthy humans appear to have accumulated body burden, and they show that it stores in lipid reservoirs. And basically what they say is that even if you're clearing out BPA well, you could get toxic like immune complexes and things that build, and things accumulate. And basically what it's saying is the little tidbits like this: patients with abnormal hepatic biochemistries also been shown to have a higher frequency of autoimmune diseases. People with higher toxic burdens, people with more toxic defects, detoxification defects, like SNPs, genetic SNPs, methylation SNPs, cytochrome P450 SNPs, glutathione SNPs, different genetic predispositions, they are more associated with autoimmune disease because they accumulate toxins more. Toxic loads deplete hepatic tolerance, which leads to the overactivation of the innate and adaptive immune system and development of autoimmune diseases. So, and it just keeps going and going and going and showing all these different things. There's a ton to this. But let's look at this. So here's BPA, and it's a thyroid endocrine disruptor on one hand. So it's going to jack up that hormone. On the other hand, it's a xenoestrogen. Xeno meaning foreign, so it's a foreign estrogen. So it's an endocrine disruptor over here. Because of this, it's going to deplete glutathione. This is glutathione recycling and oxidize to reduce glutathione. That's a big deal because when you deplete glutathione, then you can activate the immune system and turn on inflammatory pathways like NF-kappa B that leads to immune activation and autoimmunity. And that can be a self-amplifying loop, so once it's turned on, it can be kind of hard to turn off. It can also affect detox pathways. So here's phase 1, here's phase 2, and in phase 2 we have glucuronidation, we have glutathione, we have sulfation, but it just shows some of the pathways by which this is cleared out. Then this one is a little simpler, but it just shows that BPA disrupts cytochrome P450 enzymes, which do a lot of detox. They're expressed in many, if not all, your cells, but highly expressed in the liver. And so because you get those disruption of those enzymes, you get a lot of ROS, reactive oxygen species, and you get more activation of immune activation, and you get more autoimmunity, basically. That is actually pretty cool, but that's some of the mechanisms, again, by which this happens. It also has an impact on prolactin synthesis. Prolactin is associated with autoimmunity in many different correlations. There's one in here. Oh yeah, it says increased prolactin levels associated with anti-DNA antibodies, so your lupus, your Sjogren's, things like that. Islet cell, type 1 diabetes, thyroglobulin, thyroid peroxidase, Hashimoto's thyroid, adrenal cortex, 21 hydroxylase type antibodies, and transglutaminase antibodies. So you could have skin glutaminase, gut glutaminase, like in celiac, or you could have brain glutaminase. In lupus, diabetes, Hashimoto's, Addison's, and celiac. So that's another one of the mechanisms that it disrupts prolactin. Disrupted prolactin's found in all these diseases, blah, blah, blah. Here's how it happens. Triggers different cells in the pituitary, basically to increase prolactin. And then the impact on immune signaling pathways. That's where we're really getting into like autoimmune mechanisms, actually. So that's a lot. Stimulates different things. So it stimulates that estrogen receptor and basically turns on all these things like production of TNF alpha, T cell activation, dendritic cells, and that can all turn on autoimmunity. Or here's another one that hits that estrogen receptor and turns on these transcription factors. Like this is a signal transducer and transcription factor. So an activator of transcription. So like STAT3 is a big deal in autoimmunity. And it can turn these things on through cyclic AMP and MAPK, and then it turns on autoimmunity. You don't need to know any of the details. I'm obviously skimming a lot of these details, but these are some of the mechanisms by which this happens. Now, it also does some things with cytokines. So BPA to the naive T cell is going to cause polarization towards more of a Th2 phenotype generally, but it's going to activate Th17 cells, and it's going to suppress naive T cells becoming regulatory T cells or Treg cells, FOXP3 Treg cells. And that's going to lead to autoimmune, basically, and it's going to throw off immune balance, Th1, Th2 immune system. I already mentioned it once, but I have a whole podcast about that. And then I think this is the last one, but bacterial translocation of LPS with BPA triggers INOS and in nitrosative byproducts, nitric oxygen, reactive nitrogen species and things. Also triggers T cells to produce IL-4, which is a Th2 cytokine. The primary Th2 cytokine turns on mast cells, causes naive T cells to become Th2, etc. So there's a lot of mechanisms here. Now I'm starting to like just kind of skim because I can feel your head spinning and I'm not even you. So here's another one. BPA can bind to host proteins, and that changes the protein. So then that protein is then now foreign. So then it's marked as a foreign protein and an antibody is formed against it. Many mechanisms here. Now, a lot of this, again, as I mentioned, activates Th17, and this is a picture of it all together. So it's heavy stuff. There's a lot of mechanisms, but a lot of these have been further elucidated now through studies and through research, and it's been confirmed. And just, from a clinical standpoint, again, I see people have triggers, have flares of their rheumatoid arthritis because of the coffee cups that they're sipping and different things like that. So we see this as an actual real-life application. And there's science out there showing the mechanism that's obviously pretty heavy. And then there's science out there now showing the connection on a big picture, larger scale study type of thing of people with autoimmunity tend to have more exposure to these toxins anyway. This is a heavy one. Let's see how long. A little bit longer than a lot of the others, but a really, really good one, and ties together with our recent podcast episode. Find that on iTunes, or I'll link it, or anywhere else where podcasts can be found. The Autoimmune Doc podcast, it's called.